Hello everyone, and welcome back our class. Now we will study chapter 2, the first law of thermodynamics. Here is the energy equation. Last page just for closed system. This section we discuss the energy equation of an open system. For simple discuss this section, we think the flow is steady flow. Outside from the open system, the flow is steady flow. So we think this system is steady flow system. Means the properties, the state parameters have no relationship with time, no relationship with the time. Firstly is push work and flow work. Though the gas from outside goes into the system, we have to push it. So there is some push work. The push work is minus F1 times L. F1 is we push the gas the force. L is the gas moving the distance. So F1 point L is we give the system. So from the outside give the system is minus. So also is minus P1 A1 dot L. We find A1 dot L just is the volume of the gas. So W push 1 just is minus P1 dot V1. Here is a moving picture. Here's another moving picture. For a steady system, the part fluid goes into the system. Certainly, another part fluid must goes out from the system. There is no mass storage in the system because the system is steady flow. No mass storage in the system. We know from the input, the gas into the system, and the gas from system goes out into the surroundings. Certainly, there is different velocity and different height. There is some potential energy change. So last page we have learned W push 1 just is minus F1 dot L1 is equals minus P1 A1 L1. Finally is minus P1 V1 because push work is outside give to the system. So it is negative. In the same way, some fluid V2, M2 will be pulled out from the system. So some work will be done by the system. So W push 2 is P2 V2. No minus. It is negative because it is provided to the outside. So some of the push work, inlet and outlet, can be called as the flow work, just keeping the flow process. So WF, F means flow, equals W push 1 plus W push 2. Because W push 1 is minus, so it is minus P1 V1 and plus P2 V2. Finally, we can find it is delta PV. Here is a steady flow system. This system includes so many meters. Input, output, maybe outside give some heat energy to the system. The system gives some work to the user outside. So the height also is different. So includes some potential energy, kinetic energy change. So For this system, we can build the energy balance equation. During some time tau, system absorb heat Q. Also, the system provides some work W for the people, for the outside. The energy sent into the system, but the mass goes into is E1. E1 means total energy. Certainly equals U1. U1 is the internal energy included in the mass, and the kinetic energy and the potential energy equals U1 and 1/2 mc1 power second plus mgz1. At the same thing, the energy carried out the system by the mass is E2 equals U2 and 1/2 mc2 power second and mgz2. Here is goes into and goes out the total energy by the mass. Besides keeping the flow, system still provide the work for the people. The used work, we use WSH to express it. Also, we can calculate the whole work exchanged between system and surroundings. W total equals WH, WSH, and W flow. WSH is system provide the useful work for the people. WF is the flow work, keeping the working fluid flow, equals delta PV. So, in case of steady flow, based on the conservation law, the energy entering must exactly equal the energy leaving. Just to say, into the energy must be same as outside from the system the energy. So the Q is outside, give the some energy to the system, must equals W total plus E2 minus E1. This equation just from the first law. W total is WH and delta PV. E2 equals U2 and 1/2 mc2 power second and mgz2 minus E1. E1 is U1 plus 1/2 mc1 power second and plus mgz1. You can find here is just from the first law, from the energy conservation law. But this equation includes some state 2, state 1 from the input to the output. From this way, we can obtain U2 and P2V2 minus U1 plus P1 V1. We can find these two terms is very similar, U and PV. So we give a special concept and enthalpy to express U and the PV. Also, the kinetic energy difference just is 1/2 m C2 power second minus C1 power second. And potential energy just is a difference, mgz2 minus z1. Final term is WSH. So you can find if we use H to express U and the PV, this equation become very simple, very small, very short. So is Q equals H2 minus H1 and 1/2 m delta C power second mgz plus WSH. Here is the energy balance equation. Okay, last page we have learned H equals U plus PV. We think this parameter is an enthalpy. So enthalpy is the sum of internal energy and the PV term. H is equals U plus PV. We can call it enthalpy. So H is a property of the fluid, consists of properties because U is property, P and V also is property. So H also is property, is state parameter. Enthalpy is a basic energy flowing in or out system with the mass. Use the enthalpy concept about equation can be written Q equals delta H and kinetic energy difference, potential energy difference, and useful work WSH. For unit mass, we can gain small q equals delta small h and kinetic energy and potential energy and WSH. If the process is a small process, we can obtain very important the energy balance equation delta Q equals dH and 1/2 m dc power second plus mg dz and plus delta WSH. Here is for very small process the equation. Because this equation is still very long, so here we order another concept is technical work. We find the potential energy and kinetic energy and useful work. This three term can be used to work in technique. So we order WT equals these three terms. Technical work is the work which can be used by humanity. Therefore, last page, the very long equation can be shortened. Delta Q equals dH plus delta WT. WT is technical work. For limited the process, Q equals delta H and WT. It has to be the same layout with the closed system. We can do some comparison. Delta Q minus delta U equals delta PV and the technical work. A comparison of an open system with closed system. We know for a closed system, the first law is Q minus delta U equals W. W is tension work. For open system, we obtain Q minus delta U equals delta PV and WT. WT is technical work. So from these two equations, we can find W expansion work just is WT and delta PV. We can do this comparison. If the time the process is very small, it's not so big, it can be found the technical work and flow work just is coming from expansion work. Also, we can do some change. We obtain WT is W minus delta PV. If in a reversible process, we know W is PDV integration. WT equals W minus PV. We can do some change, do some calculation. W just is 1 to 2 PDV. Delta PV just from 1 to 2 dPV. So we can do some change equals 1 to 2 PDV minus 1 to 2 VDP minus PDV from 1 to 2. Finally, we can find WT just is minus integration from 1 to 2 VDP. This equation expressed in the PV diagram, we can find just is here is PV diagram. The process line is from 1 to 2. The WT just is this process line shadowed to P-axis include the area. Just is the technical work. Thank you very much.